Page 31, lesson 1.5 is on solving equations using square roots and cube roots. So if you look on page 31, Janine can use up to 150 1-inch blocks to build a solid cube-shaped model. What are the dimensions of the possible models she can build, and how many blocks would Janine use for each model? So notice some key words in here. She's going to build a solid cube-shaped model. So one thing, it's solid, so it's not like we're just putting these cubes on the outside. We're making it solid. Also, it's a cube shape. And also, we can use up to 150 1-inch blocks. So let's think about some different cubes that we could make if we have a total of 150 blocks that we could possibly use all together. So one thing to start off with, our length, volume is length times width times height. So one possibility would be 1 by 1 by 1, and that would be just using one cube. If our length, width, and height was all 1, that would just be using one cube. So that's one possibility. Obviously, if we've got 150 blocks all together, 150 of these little cubes, you know, we may want to use more than just one of them, but that's one option. Another option, we could have 2 by 2 by 2, and that would be altogether 8 cubes. If we just continue on, another option would be 3 by 3 by 3, and that would use 27 cubes. 4 by 4 by 4 would be 64 cubes. 5 by 5 by 5 would be 125 cubes. And then we could try 6 by 6 by 6. If you multiply that out, that would be 216. We only have 150 cubes available, so that's going to be too much. So the biggest cube-shaped model, solid cube-shaped model, would be 5 by 5 by 5. That'd be 125. So we'd have 25 left over, but that's the biggest cube shape that we could make with the blocks we were given. Example 1, Darius is restoring a square tabletop. He wants to finish the outside edges with a piece of decorative molding. What total length of molding will Darius need? Okay, so we have a square tabletop. He's going to finish the outside edges with decorative molding. So this, basically this molding we're talking about is going to go all around the edges, all 4 sides. Okay, so the total length of molding he would need. So first of all, what the book did is they said, well, it's a square, so we could do length times width, and then they went ahead and noted that the length and width would be the same since it's a square. So you'd say s times s, which is the same as s squared. So I'll just write a couple other things here the book didn't, if you can't follow their progression too well. Okay, so length times width, and then the length and width are both the same. S times s is the same as s squared, and they told us the area was 25. So that's s squared. We want to figure out what s is, which is what our side length is. So I talked about it a little bit previously in the last section. If s is being squared, we're going to do the opposite operation. So if it's being squared, we're going to take the square root. Technically, when we take the square root, we should add the plus or minus sign in front of it. The book notes that off to the side that, you know, 5 times 5 is 25, but also -5 times -5 would also be 25. Now we know in this case The side length can't be negative, so we can cross that off, but technically we do have that option. As you go along, just something to remember is whatever the highest exponent you see on a variable, that's how many possible solutions. So since we have the second power, that's telling us we have 2 possible solutions to this problem. In real life, they don't always work necessarily, but they're potentially 2 possibilities. So that's telling us that our side length is 5, so that's 5 feet. And then after we do that, the book didn't really show much work of how they finished this off, but if one side is 5, multiply that by 4, then they would need 20 feet altogether of decorative molding. So if we look at the try it, we've got a similar situation. Not quite as much going on this one. They're just asking what is the side length of the square below. So again, if you want to start out with area of a rectangle, and then we could say in a square the length and the width are both the same, and then that can take us to the point of where the book is over here. Oops. They told us the area is 100, so we can put that in place of the A. So since that's s squared, we want to figure out what s is. We're going to do the opposite operation. We're going to do the square root. Square root gets rid of the square. When we add that square root again, it would be good for us to put plus or minus, just to at least consider the possibilities. So that would be 10. 10 times 10 equals 100. We'll keep our plus or minus there. And then the other side, instead of the s squared, they could have went ahead and just put s, because square root of s squared is s. I think maybe they're wanting us to do something different on that step, but anyway. So we get to this point, we got plus or minus 10. And then we can think about that we're talking about the sides of a square. So on a square, a side could be 10 meters long, it can't be negative 10 meters long. And so at that point we can cross out the negative. And then over here, then we could say each side of the square measures 10 meters. Example 2, Kyle has a large cube-shaped terrarium for his iguana. He wants to cover the opening with a square screen. What are the dimensions asked for the screen? So for this problem, to start with, they're telling us the volume of the terrarium. Since it's a cube-shaped terrarium, first of all, it's a rectangular prism. So to find the volume, we do length times width times height. And then it just happens that the length, the width, and the height are all the same since it's a cube. So s times s times s, that's the same as s cubed. And now we can start substituting in. So the volume, like the book shows from this point, the volume is 343. And then this time s is being cubed. So to get rid of the cubed, we need to take the cube root. So if you do the cube root of 343, you'll get 7. Notice on this problem I did not add the plus or minus. If you do a cube root, we don't need to add the plus or minus, only if you do a square root, okay? Only an even root, I should say, I guess. We won't get into it, but we could do a fourth root of something also. But anyway, with this, it doesn't work because if you had 7 times 7 times 7 equals 343. If we had 3 negatives multiplied together, that would actually be a negative 343. So that can't work. So we actually don't, on the cube, if we do the cube root, we actually don't have to add the plus or minus. So the 7 is each edge length we're trying to figure out for the square screen. So if it's a 7 by 7 by 7 cube, then like the book says, the edge dimensions of the screen should be 7. So 7 feet by 7 feet should be the dimensions for this. So it's a pretty good sized terrarium there, I would say. 7 feet by 7 feet by 7 feet. So if we look at the try it, they want us to solve x cubed equals 64. So since x is being cubed, we can take the cube root. So that's, sorry, that was a little sloppy there. That's the cube root of 64. So cube root of 64 is 4. Again, since we did the cube root, we don't need to put the plus or minus. So our answer is 4. A way of checking that answer, we can substitute that back in place of x and see if this works. So if you do 4 cubed, you should get 64 if that's the correct answer, and you will.